So for this problem, we have a rocket starting from rest. It launches. It goes. So the engine is, the rocket is just blasting this rocket into the sky. And we're given the acceleration for this first part as 29.4 meter per second squared for a time of 4 seconds. Now, after the 4 seconds, the engine dies. Now, what's the significance of that? If the engine dies, are we going to have just, will the rocket be blasting anymore? No. So as soon as the engine dies, the acceleration, is it still going to be 29.4?
No, it's going to slow down.
Well, the acceleration is going to change to what?
To 9.8.
To negative 9.8. It would be the same as if you took a baseball and threw the baseball up. As soon as the baseball leaves your hand, what's the acceleration? Negative 9.8. So the acceleration for this second part is gravity, which is negative 9.8. Does that make sense? So look, the rocket's going like this. It's going faster, 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 faster in the upward direction. Our sign convention for the whole problem is up is plus, down is minus. That's for the whole problem. So why is this first acceleration plus? Because which way is the velocity changing? Up or down? Up. The rocket's going faster, faster, faster upward, right? Now, as soon as the engine dies, which way is the velocity changing? Down. That doesn't mean it's going down. That means it's going to go like this. It's going to go slower, 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 and then what happens up here? At the tippy top, what happens? V goes to 0 for a split second. For a split second, the velocity goes to 0, and that's the maximum height. Up here is the max height. Okay? So what I'm really getting at here is we have to split the problem. We got to break it into two parts. So the two parts are going to be, I'm going to put a red line right here. So the first part is where we have an acceleration of positive 29, and then the second part is where the acceleration is negative 9.8. Wherever the acceleration of an object changes, you have to split the problem. Wherever the acceleration changes, you have to split the problem. All right, so now let's look at the questions. First question, how high is the rocket when the engine dies? So this question is asking for this. From the ground to where the engine dies. We're looking for this, okay? So do we have enough info to do it? Yeah. We can do part A with the information we have. We just go x equals 1/2 at squared plus v initial t. What's the initial velocity for this first part? 0. So that part goes away. And you go x equals 1/2 positive 29.4 meter per second squared for a time of 4 seconds. And make sure you square the time. So that gives us an answer of 235.2 meters. So that's the height of the rocket when the engine dies. Okay, question B. After the rocket engine dies, how much time does it take for the rocket to reach the maximum height? So we're looking for the time for the second part. So we want the time from here, from where the engine dies, to here, right? What is the time for this journey, right? Do we have enough information yet? No, we do not. We can't solve for this in one step. We have to find something first. What do we have to find first? We first need to find the velocity when the engine dies. The final velocity of the first part. So the rocket's going to be going faster, 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 faster. we need to find this velocity at the moment where the engine dies. How do we do that? Nathan.
We pick the third equation, Vf equals V initial plus A times T.
Nice. Okay, what's V initial?
0 meters per second, so we
Zero.
can get that.
So the final velocity at the end of the first part is going to be A times T. The acceleration for the first part is 29.4 for a time of 4 seconds. So the velocity at the end of the first part is going to be 117.6. Man, that's moving. That must be a rocket. Oh, wait, it is a rocket. Okay. 117.6 meter per second. Now, can we solve for the question?
Yes.
Yes. Now that we know the velocity at the end of part 1 is 117.6, so what do we now know about part 2? So this becomes the initial velocity for part 2. The final velocity for part 1 becomes the initial velocity for part 2. You guys follow this?
Yes.
So now the rocket goes like this. It goes slower, 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 because now the acceleration is negative, right? Gravity is pushing the rocket down. So let's solve it. So we're looking for time. Okay, so we're still working on part B. So what equation could we use to solve for this time? What? Nathan?
V final equals V initial plus AT.
Same equation. Okay, only now up here, this is V final. At the very, very top, that's our final. So what's V final up there? 0. So now we can solve this for T. So T, when you do the algebra, you get negative V initial over A. So that's negative 117.6 divided by negative 9.8. So that the negatives cancel. You'll never get a negative time. Time cannot be negative. So this gives us 12 seconds. So that's the time from when the engine dies to the maximum height. All right, any questions with that? You guys get the hang of it, the feel for it? All right, part C, what is the maximum height above the ground? Well, look, we already know the first height. Didn't we calculate this already? We did. Did we calculate?
Yes.
What was this first height?
235.2.
So this was 235.2. So look, the total height above the ground, is going to be this, right? But we have to break that into two parts. So we'll call this x1, and then we got to find this, which is x2. Okay, so it's two different calculations. We already did the first calculation. The first calculation gave us 235. That's the height when the engine dies. And then the second calculation, we got to solve for how much higher the rocket goes after the engine dies. Okay, so do we have enough info to solve for x2?
No.
I think we do. Yeah, we totally do. We could go like this. We could go v final squared equals v initial squared plus 2ax. Or you could have done, I mean, there's lots of, in fact, you know what? 3 of them work. You could do this, 1/2 at squared plus v initial t. That one would work. Or you could do 1/2 v final plus v initial. So 3 of the kinematics work. Which one looks the nicest?
The second equation.
You think the second one?
The x equals
Last
1.
one.
Oh, I think the last one. This one looks the easiest.
I meant that one.
That one? That one's the easiest. So let's do that one. Okay, so we're going to go x equals 1/2 v final plus v initial times t. What's v final at the tippy top? 0. So x2 is going to be 1/2 v initial, which is 117.6 for the second part. And then the time was 12 seconds. The time for the second part was 12 seconds. So this gives us x2 as 117.6 times 12 divided by 2, 705.6. So what's the total height? The total height of the rocket, you're going to take x2 and x1, 940.8. Okay. So look, now why would I not put, I mean, I could give you something similar on the quiz, but I'd give it to you like more digested ahead of time. You know, this was like raw here. This would not be a good multiple choice question just because there's so many steps, right? Multiple choice questions tend to be like more to the point, less steps.
This is mainly a midterm, right?
This is a good midterm question where I'm grading your work, the free response. All right.